So far, we have seen that a quadratic equation can have two types of solutions. One is you can end up with two real numbers. Another one is you can end up with just one real number. In this video, I'm going to introduce a third type of solution, which is a complex solution. So how many types of solutions altogether can a quadratic equation have? The answer is 3. Now, in the formula, the quadratic formula, x equals negative b plus or minus square root of b squared minus 4ac over 2a. The radicand, the part that is inside of the square root, this part is called the discriminant. By looking at the discriminant, we can determine what types of solution we are going to end up with without actually solving the whole thing. So if the discriminant b squared minus 4ac is greater than 0, then we can expect to have two real solutions. If the discriminant is equal to 0, then we can expect to get one real solution. And if the discriminant is less than 0, at this point we are going to look at a negative number inside of a square root. Then we should end up with two complex solutions, or two imaginary solutions. So let's do two examples here. The first one, negative x times x minus 6 in parentheses is equal to 11. Now the first thing that we want to do is to move everything over so that the other side is 0. We can also at the same time distribute this. So this will be negative x squared plus 6x, move 11 over. We get this. Now I want to get rid of that negative in front of that x squared, just in case if I would decide to factor, it'll be a lot easier. Or even if you use a quadratic formula, it will be easier as well. So I can divide both sides by negative 1, everything by negative 1, and that will give us x squared plus minus 6x plus 11. So as you can see, I am reversing all the signs, and then over here 0 divided by negative 1 is still going to be 0. Now let's use a quadratic formula. So here a is 1, b is negative 6, and c is 11. So x is equal to negative b, which is negative 6, plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, so simplifying two negatives make a positive. Simplifying the radicand under the square root there, we are going to get, that's positive 36, negative 6 squared is positive 36, minus 44. Looks like we are going to end up with a negative number. So we can expect to get two imaginary solutions. That's going to be square root of negative 8 over 2. We can simplify this further. Square root of negative 8 will become I square root of 8. And square root of 8 can be factored as 4 and 2. I want a perfect square there so I can pull it out. So 6 plus or minus square root of 4 is 2. So 2i square root of 2 over 2. Now I can just divide each term in the numerator by that 2 in the denominator. So that will give me 6 divided by 2 is 3, plus or minus. The 2 and 2 will cancel. So that will give us I square root of 2. So as you can see, we ended up with two distinct imaginary solutions, and they are 3 plus I square root of 2 and 3 minus I square root of 2. Let's try this next example. And again, I'm going to be using the quadratic formula. Let's try to detect to see what kind of solution we are going to get this time also. So A here is 3, B is 2, and C is 9. The discriminant can be calculated by b squared minus 4ac, which is 2 squared minus 4 times 3 times 9. Now that will give us 4 minus 4 times 3 times 9 will give us 108. So we will end up with negative 104. Now since the discriminant is negative, which is the third scenario that we mentioned here, we should expect to get two imaginary solutions again. So let's solve. So the quadratic formula, negative b plus or minus b squared minus 4ac over 2a. And that is negative 2 plus or minus, we already calculated the discriminant, that's negative 104 over 6. Now, the square root of negative 104 will become I square root of 104. Now we gotta think, is there a perfect square that goes into 104? And the answer is yes. We can factor that as 4 times 26. Of course, 26 can be factored further as 2 and 13. However, neither one of them is a perfect square, so it's not gonna come out. So we really just need that 4. Okay, so then square root of 4 will become 2, which will bring to the outside here. So 2i square root of 26 over 6. Again, I am going to split this up. We're going to divide each term up here by the denominator 6. So it's going to look like this. Okay, negative 2 over 6, that's going to be a fraction. So that's going to be negative 1/3. Plus or minus 2 and 6 there. 2 divided by 6 will give you 3 on the bottom. So I squared root of 26 over 3. So again, we're ending up with two distinct imaginary numbers, which are negative 1/3 plus I squared root of 26 over 3 and negative 1/3 minus I squared root of 26 over 3.